Ladies and gentlemen, let's warmly welcome our first speaker, Joerg Krämer.
Thank you, Dexter. That's my water. Yes.
I'll keep it.
You can take your own water. Yeah? Yes. Functional safety meets cybersecurity. I saw a lot of oil rigs and oil plants when I came from the airport here to the hotel, and in all of that we had this safety functions. Safety functions, what is it? I think I will start with a short explanation what functional safety is, and then what functional safety versus cybersecurity means, and a short overview about these both standards, the 61508 and the 62443. Who heard about something about 61508? Hands up. 1, 2, okay, 3. 3 people. So then it is necessary to explain a bit about that. What means functional safety? Functional safety means that functions work safe. And here, for example, we have a big turbine. And in that big turbine, we have a lot of vibrations. And if the vibrations are too high, the turbine will be destroyed. So for that, we have some sensors. You see here on the right-hand side, from you the left-hand side, a sensor, vibration sensor. And this vibration sensor sees we have more vibrations than before. And before the vibrations are too high, the machine will stop. That is a typical safety function. But the safety function also works if you have any faults inside. So the function have to work with faults. So that is quite different to all our products which we can buy today, yes? We buy some mobiles, PCs, some devices, and each device, what we buy, is not really completely finished. So you need a service update. The first is what you see if you buy a big TV. You connect that TV in your home. You want directly connected to the WLAN, to the Wi-Fi. What happens? The TV asks for a new software. So that is a point what not could be happen in the functional safety topic. Functional safety means it has to be safe directly for the next 30 years. And it doesn't matter that you have, for instance, a special fault like that random fault. A tool, a hammer for instance, is falling down to the sensor, disconnect that sensor, in that moment you have no vibrations. The system thinks there are no vibrations, but in reality you will have vibrations, and that means the vibrations are so high that the complete engine could be destroyed. So that means functional safety. It means you have to detect random faults, you have to detect systematic faults, and in the development you have to avoid systematic faults. And that is a typical case in a lot of your plants and in some applications. It's not only the process area, it's the machinery area also, the medical device area, the automotive area. You want to rely on a function, and if that function is not working, some people could die. But it stops not complete in the system. I heard something about the system today. Everybody is talking about the complete system. The system has to be safe. No, it starts with the PLC, the programming logic unit, the controller. What could happen inside of that? In that controller, you have normally a schematic board. And on that schematic board, You have a microcontroller. And in that microcontroller is a RAM cell. And in that RAM cell is one bit which we want to set to 0 to stop the engine, but because of an internal RAM fault, it is still on. So the machine could be destroyed also. That means not only the system have to be safe, a product have to be safe also. And now we will see what is the difference between security and safety. Safety means, here you see it, defensive against random and systematic technical failures to protect life and environmental. And the cybersecurity talking about the willful actions. And that's quite a different, yes? Random and systematic faults, you can calculate, you can build, develop your complete system with some very safe products, and it will be safe for the next 30 years. Cybersecurity is a bit different, that we heard. What today is secure could be that tomorrow is not secure. We talked about the difference between IT systems and the industrial control systems. I will not repeat everything, but one big point is system lifetime. Normally in the industrial control systems is 20, 30 years. And yes, in the IT branch, you see normally, yes, your PC, you will buy each 3 years a new PC, and it's much faster. And the next point is time in the IT branch. Doesn't matter, yes. Faster is better, yes, like a car. But normally, if you press a print button and it is not directly printing out, doesn't matter. But here in the industrial control systems, think about the safety function. It could be that people could die because of that function which is too slow. And that is really hard to understand for these IT experts. I think sometimes it would be better to make a system secure not with an IT expert. Better is you have an industrial control system expert and push him up, train them, that he know to understand what cybersecurity is. Because it is much harder to understand the necessities of these industrial control systems than these IT systems. That's my opinion, and I built some systems in the past. So if we have to separate that, it makes sense that we have here a separation, industrial control system on the one hand and corporate IT system on the other hand. And I heard today that it is a good idea to separate that and build one firewall between this. And that's it. And what is with the products here? What is with each controller which is installed in that system? Mr. Mohammed, you told me we have to rely on the people, yeah, the complete plant, and the system. And say not the system. You have to rely on each product. That is the point. Today we saw one of that hard disk, and in that hard disk a virus was installed. I heard something about that hard disk virus. You could buy a hard disk in an electronic shop in Germany, and the virus was directly installed on site, on this hard disk. Yeah. So you have to rely on the products also, and that means the security have to be inside by design. That means in the development phase, you have to follow some functional requirements, for instance, the identification of authentication control or the use control. Yes, that an administrator can do everything, but not the operator. Yes, system integrity, restricted data flow. It is really nice that everybody can now connect his own mobile phone directly with the complete power plant. Makes this very impressive. Yeah? You can show that another CEO, yeah, if you play golf here, I can switch on and switch off my power plant. Huh? It's great. The problem is then everybody could do that. We have to think about what makes sense and what makes no sense. What we can use, what now is really secure. And in the moment, we have a lot of systems which support some nice functions, but these functions are not secure. And for functional safety, we have the same to do. We have to follow the requirements for functional safety. That means we have to use good diagnostic measures. We have to build a good hardware architecture. We need low failure rates. And here, for example, systematic safety integrity, we need a safety management system. And today we heard something about security management systems, yes, and that is nearly the same. So the difference between safety and security is not so much. So it would make sense to think about what is the route for safety and security. And the 61508 is the umbrella standard for each branch for functional safety. And here in this sentence you see, if as being reasonable foreseeable, then a security threat analysis should be carried out. And you see, you have to do that according to the IEC 62443. That is a standard which explains how you can develop products and systems and, yes, the complete handling of that cyber-secure systems, power plants, and these simple products. The standard works with life cycle phases. So we start always with a concept, and we're doing an overall scope definition. And on the left-hand side, you see here the functional safety. You have to do a hazard and risk analysis. And now you have to do, for cybersecurity, also a risk analysis and to see what are the threats. For the safety, for the functional safety topic, you have to follow then a safety integrity level. ZIL, it calls. And as higher the risk is that something happens, as better, as higher your ZIL have to be to reduce that risk. For instance, the pipeline. If the pressure is too high, it could be that some people could die. Yeah? And you have to make this risk analysis to see how good this pressure sensor and the PLC have to be. ZIL 1, ZIL 2, ZIL 3, ZIL 4. And ZIL 1 means one fault could happen in 10 years. ZIL 2 means 100 years. ZIL 3 means one fault in 1,000 years. And ZIL 4 means one fault in 10,000 years, a random fault. You can calculate that. And now for cybersecurity, we have the same. We have the security level. And security level means, for instance, if you have a possibility to switch on and switch off these pressure sensor, yes, then these switch have not be directly, or you cannot use that switch directly. You need a tool for that. That is ZIL 1. So that it is not possible that you talking to your colleague and playing here with the pressure sensor and switch it off. That is ZIL 1, SL1. SL2 is more that level script kiddies, yeah, that children which want to change something And for instance, in Hamburg, we have a big harbor, and there was a crane installed, very big crane, and this crane was controlled by a PLC, which was not saved by a password. Yeah? Directly, everybody could move the crane. So people there thought, oh, it is EMC or something like that, yes, electromagnetic vibration or something like that. No, it was open in the internet, everybody could change that. SL3 and SL4 is not directly achievable only with a PLC with one product. For that you need your complete system. For that you need typical things like walls, doors, access systems, and something like that. In the 61508 we have a special development system that called the V model, and that means that you have to develop your system or your product step by step. You start with a requirement specification, you have to build your architecture. For instance, do you want to use 1 or 2 pressure sensors? Do you want to use 1 or 2 PLCs? And the last step here, the bottom is then the coding, and the right branch explain then the test cases, what you have to do to test. And in the 62443, I never find that V model, but each developer, each system integrator knows what a V model is, what you have to do, and for that we built from the TUV Rheinland a V model especially for cybersecurity. So you have to do the security management, you have to specify security requirements, you have to build a secure design, you have to do secure implementation, module verification, and security verification and validation. Yes. The point is, and that's the big message, it is not necessary to develop firstly a safe system and after that a secure system. You can do that in one step, in one development. Yes, here that is for product vendors. I explain a bit more here for the system integrators. We have here system design and architecture phase and the installation phase. For functional safety and for cybersecurity, you have to do something, and sometimes it is nearly the same. Some tests which you use in functional safety topics you can use also for cybersecurity. That is often the same. And so you can build a complete safe and a secure system, and it is not, you have nothing really more to do. But you have to take care that you fulfill all these requirements according to that standards. Here, for example, we have the product or the system development requirements, and we have some functional safety requirements, and we have some functional security requirements. And a functional safe device, a PLC, have embedded code. Yes, the C code or that assembler code, which fulfills the function of this PLC. And a typical test is for safety products that you have to make a lot of tests according to the requirements, what this PLC have to do, and after that you have to look, is each coding line, is each instruction, was each instruction covered? That means each of that instructions have to fulfill these requirements. And if there is code which never is used, has been used, then this could be the backdoor for the hackers. And the same we have for cybersecurity. It is the same test. After that, we have to see which possibilities the hackers have. SL1, SL2, I told you that it is not possible to build a PLC or pressure sensor directly with an SL3 or SL4. Because of, yes, anybody could go to the sensor and disconnect it. And for that you need then the complete system. You need your plant, you need your doors, you need your walls, you need your access system. What we have seen, functional safety and cybersecurity standards consider the product lifecycle from specification over design to operation and maintenance. It requires risk and threat analysis, needs to specify safety and security level, requires organizational and technical measures, and needs to consider fault avoidance and fault control. Operators push requirements from the cybersecurity. That isn't the moment the fact. So you have to ask the product manufacturers for security level. The regulation by law will follow. So some of the product vendors start with the development or have finished the development, and more the government of Germany is in discussion what we have to do because of cybersecurity. And no safety without security. Yes. I see here on the little screen the end of my time is coming. And I will explain you some additional information. I will give you some additional information. In Germany, we have only one word for safety and security. Something that is a bit funny, yes, in discussion. What you mean, safety or security? But we have only one word, and I think it fits. And it's called Sicherheit. Thank you.
Now, Joerg, we do actually have a couple of minutes for some questions. So, ladies and gentlemen, I'm going to throw it over to you, the audience. Remember, at these conferences, we try to empower you by giving you a voice as well. So, if we could possibly just dim those lights for me to see some hands in the audience. If you've got a question, may I ask you to raise your hand and give us your name, your company, and your question. Again, if you've got any questions, we encourage you to interact with our speakers and our presenters. If you've got a question, give us your name, your company, and your one question. Well, it would appear, Joerg, that with your German exit there, you've left them all stunned. Ladies and gentlemen, a big round of applause, please, for Joerg Krämer for TUV.